You had some questions, some interests. So you've been reading.
Yeah, I've been reading and just I'm, I'm just going through again going through the course and stuff like that. Just keep going through it because what I want to make sure that I don't do is become dogmatic in my approach.
Mm-hmm.
Because what I can see happening is obviously I can never know what you know. So my aim is to try and know as much as you know, then try and get above that, if that makes sense.
Well, add what you're adding what I know to what you know,
Exactly.
which is hopefully creating some new knowledge and some new perspectives, and that maybe you'll see something that I couldn't see, and then you can tell me something, right? I mean, that's hopefully how the process works.
So like everything that I'm seeing and reading, it's like, especially within the course. Okay, what? Cause my neurobiology, neurophysiology stuff isn't amazing because I'm pretty new to it. So it's like learning about the stuff I essentially went through and learning, reading, doing the research myself, and reading what you've read to come to the conclusions that you have.
What are you seeing?
But just like the cranial nerve column, I've never heard of that, and so I just wanted to try and find out a little bit more about that. What got a steer on where I should be putting my attention on it, as well as everything. Add it to the list of things.
The never-ending thing, isn't it? Yes,
It kills me because I'm very I'm pretty OCD about things. Completing things is a big thing for me. I need to try and complete stuff. So that's something I've got to work on, I suppose. But yeah. And then one of the questions I suppose that could be answered pretty quickly is in terms of the cervical effects screen. Why is it that you choose what if in the? I'm trying to think of the one. One of the I can't remember the screen. Might be the ocular screen that you use the shoulders as the screen, and the cranial, the cervical effects you use the hips. Like why is that choice? If we got the cranial nerve pools and the nerve column and the neuron pools that propagate to the shoulders, why do we use the hips?
Yeah, that's a good question. It's I think my initial answer would be that I was introduced to the concept in another organization, and the way they were using it there was based on that dynamic, which I understand generally came from the chiropractic clinical kinesiology framework. And so I just stayed with it. But I don't know if I say this in the course, I try to say it. I think that there's probably other parts of the motor system that you could use to see if there's a change in motor output, and I would encourage you to do that. It's kind of why I keep calling those screens, to avoid the term of, protocol or, this is the cause and effect only way to do this, right? This is just one way to sort of get a quick survey of what's happening here, right? And is there a relationship between, the neck and the hip, and, mechanically, in the other column of that cervical effect screen, you can use the shoulder girdle, the upper extremity. So you can use both. I typically teach it as, if you can't use the hips for whatever reason, then you can try to use the upper extremity as a backup, if you will, but you could use that right up front if you wanted to. So, and so it gets back again to philosophy and how I think about the body. And so I would tell you that it's more a matter of convenience as far as the hips. Here you have the system in a highly stable situation mechanically, right? Yeah. Massive base of support. It's totally supported. It doesn't have to do a lot to manage its inertial segments. There's equilibrium across a lot of the joints. And you know, the hip abducted perturbation configuration seems like a pretty low risk thing, again, unless there's something in the history or surgery or there's pain associated with it, to see whether or not a change in configuration using the head neck system, alters, motor outputs somewhere down in the hip, lower extremity, trunk and spine, because the hip is connected to the axial skeleton as well as it is to the lower extremity. It kind of gives me a broader look at everything, at more of the system's reaction capability. So that's why I stayed with it from a mechanical control perspective versus switching to some other positions. Again, low risk, it's convenient. It accesses, the axial skeleton as well as the lower extremity in the perturbation. So that's why I stayed with it.
I suppose then it would incorporate some of the firing mechanisms that innervate the shoulders and the arms as well.
It could indirectly, for sure, yeah, and you could still do the upper extremity. Now, making a distinction between the oculomotor and the tongue and all the stuff that's primarily innervated from the cranial nerve column and the cervical nerve column. Again, with the cervical motion, I'm accessing the spine now, right? So because of, again, this interdependent thing, right? So you always have to keep in mind when I'm thinking about the system, not just mechanically, but which is coupled to the neurological system, right? So it's like we talk about these things as separate things to try to understand them, but they're simply not separate. The mechanical actions we see are driven by the neurological system, and so I always think of the human neurological system as a dynamic chemical electrical information processing system, that's coupled to the mechanical part of the system. And this is what builds this active learning capability, and it's fully integrated. And so when we move the neck, the rest of the spinal column mechanically has to have something to do with that. And we could build an argument just from a muscular perspective, right? I mean, you have muscles like the spinalis, the longissimus, that attach to the lower cervical vertebral system and run all the way down to your sacrum. And so by turning the neck, I'm getting indirectly and maybe even directly, based on what I just described, into the rest of the spinal column without having to stress the rest of the spinal column from a mechanical perspective. And so this fully integrated structure that has so much interdependency, is a set in my mind of anatomic communication hubs, links, and nodes, right? Remember that picture I drew about hub, links, and node networks? And that the information being exchanged between the hubs, the links, and the nodes creates a streaming connectivity that is simultaneously sensing and controlling the physical behaviors of the system in 4 dimensions all the time. And so my question is, how can I find out whether or not one part could be influencing another part, at relatively low risks, at least initially? And that's what the cervical effect screen is for. And so the ability of the system is reflected in the physical motor behavior at gross observable levels. And because it's capable of altering its anatomical structural connectivity in response to changing conditions, that variability in the structure function relationship essentially allows for what we think of as remote areas to influence other parts that you wouldn't think about influencing them. But again, even in motor control literature and sports performance training, right, the head and the neck system, along with the eyes, apparently is a real driver or influencer of what the rest of the body is doing, right? Or does. It's like an orchestrator, a director. You want to go to the left. Well, you turn your head and your neck to the left, and you start going over there, right? So there's all these coupled actions all of the time. So
yeah, it's weird, but one of the first lessons I remember from judo, so I've done judo since I was 3, was where the head goes, the body follows. So if you can control that area, you're onto a winner.
That's it, right? So that's, an observational kind of phenomenological thing. I understand that, but from a motor perspective, there's some research, I think, that kind of backs that up. Again, in the spatiotemporal realm, what's impossible for us to observe is to actually see how it works inside. We can't see the inside. So we're always working with this gross aggregate output part, understanding a priori that this internal moment-to-moment configuration of the information, chemically and electrically and mechanically and energetically all happening under changing condition, may reflect a limit in output or a potential in the transfer and management of that communication. And all I'm always trying to find is if I have you do this, does this help you with motor quality output, or does it somehow limit you in some way when I do this, right? And so these are all just sampling techniques, right? Really not meant to be exhaustive in establishing cause and effect, but just like, man, let me see if, without me grabbing your head and twisting your neck and putting you in a neck machine and attaching a head harness with a chain and a dumbbell hanging off a chain and making you move your neck and putting all kinds of mechanical stress to see if your neck is healthy and can control itself. Maybe I can get a sense of the neck's influence or capabilities and influence indirectly with less risk and stress, right, to the materials. Because when you start talking about the neck, you're talking about some pretty sensitive and fragile structures in there. And, the risk part is another reason why I maintain that screen the way that it is. And that's what's interesting about how limits and potentials are displayed as deficits or gains in specific physical motor behavior. And I see the same thing with the hand, right? Working with a client who's had hand injuries, surgeries, tendon transfers, right? All kinds of weird, crazy stuff to try to get their hand working again. And I can use this general principle to see whether or not, while they're using their hand, does it alter any other part of their synovial joint and extremity motor output. So for instance, I might have them, I'll check their shoulder abducted while they're standing or seated or supine or whatever, and do a QMAMC to see the quality against abduction, let's say, reflection at some position in the plane and the displacement. And it's pretty high quality. Then I have them squeeze something really hard in their hand, like a bar or a dowel, and then I'll recheck it. And sometimes I'll find all of a sudden their quality of their upper extremity control drops dramatically. They can't generate the same amount of response. Then I, take it out and recheck it, like I do, just to make sure I'm not seeing something or this is a trick or some voodoo thing. And then it tells me, oh, this hand, right? What's going on when the system has to use the hand in a mechanical way to generate tension and force, it's limiting the force output and production of parts of this, the rest of the thing it's attached to, right? The upper extremity. And so that might lead me to say, I got to work with the hand a little bit more to figure out what's going on down there from a quality perspective. And so that's what that does. It's just a lead generating system, and it's a simple, again, assessment process to check this influence and what limits and potentials are displayed. Sometimes I might see the opposite, right? Where someone, without gripping has low quality, then they grip hard and they have high quality, right? So something about the co-contraction with their hand helps them. And so it's like, that's interesting to me. And so, again, because local motor behavior deficits or gains, however observed and measured, could exist because of non-local influences within the total configuration, you can manipulate non-local influences to change system configuration in such a way that the locally observed motor deficit or gain or its limits and potentials could be changed. And so it just presents a learning opportunity. So I'm just saying to the system, oh, you can't read this. You're not good at doing these two things together. So let's teach you how to do that.
How complex have you gotten at that point? Now, how many things have you started? Like, again, you think of that systematicity principle. Have you started to work together? So,
a lot.
Like working on abduction at the hip whilst gripping something in the hand, whilst looking to the right.
Especially, yeah, if someone gives me enough time, and I look at the history and I look at the injuries, right, and it's that corroborating confluence of what they're telling me and what they respond, and they start to get better at describing the scenarios under which they're having trouble controlling themselves, and then I go through a mechanical interpretation and overlay that against the history and the data I have. So yeah, it's definitely four-dimensional chess, not checkers that we're playing here. And I'll start to test and run these relational scenarios just to see. And sometimes I'll see something, and then I'll do it. I'll use it, and it helps, right? It helps a lot. So a variety of system communication configurations, seems to be the way to go, because it can create and support specific gross observable motor behavior. And so when an intended motor behavior can't be created, and the observed system configuration can't be generated to support that effort, that's what gives me insight into, wait a minute, there's something not right here. You don't know how to spell this word, right? You can't create a sentence here that's comprehensible. And so I have to figure out, well, why can't you do this thing, this coordinated event, right?
So is the goal then to have the person be able to write a paragraph and then write a page and write a novel and so on?
Lots of different stories, right? How many notes are there in music?
Yeah. Nice.
There's a finite number of notes, but how many different songs can be written?
No.
So again, I understand that there has to be constraint around this system, and that, there's I call it trade-offedness, right? Sometimes you gain a skill or a motor competency, and you had to prune another one, right? And the classical example I use there is that engineer who put the mechanism on the bicycle, the upright bicycle, that when you turn the handlebar to the left, the front wheel turned to the right. You ever seen this?
No.
Right. So it was on YouTube. You might still be able to find it, right? So I think it was a neurophysiologist, biologist, a motor control guy, and he's trying to figure out, what happens here. And so he built this bike that did this. And when you give it to adults, no one could ride this bike, right? Because you get on the bike and you think, I want to turn to the left, and you turn the handlebars to the left and the tire goes to the right, and if you fall off the bike.
Yeah.
Now he found that children could do it a little bit, they could pick it up a little quicker, but adults could not, because definitely there's that soldering process, right, that happens as we age and mature, and it helps create predictability in the system. So I can understand that aspect of the continuum. And he took this bike around the world or around the country and filmed it. No one can ride this bike. And so he just keeps practicing and practicing until his brain could figure out, when I want to go to the right, I have to turn the handlebars to the left. And so he figured it out. He learned how to do it. Guess what he lost?
How to do it normally.
He couldn't do it on a normal bike anymore.
Yeah.
So it's like, what the heck, right? So the brain likes to, I think motor control people, have terms for this, these trenches, right? These effectors, and the system wants to get into the lowest energy state and stay there. What's the easiest path, right? It creates ruts and grooves and says, okay, here's how we're going to do this, for energy conservation, supposedly. And there's all kinds of hypotheses about why it's doing this, versus why does it prune connections at all, right? Why not just keep all of them? Because predictability is based on constraints, right, in the system. And so working within that is what I'm always thinking about, against the genetic backdrop, right? Training history. There's lots of things that feed into why that is. What's interesting to me is not only does it improving those simple relationships, like gripping something and using your upper extremity, which is a pretty common motor behavior for all humans, especially if you're exercising. I mean, how many exercises do you do where you're not gripping something? Yeah. While you're using your body, right? And so if gripping something is creating a limit in motor behavior that you want and that you need, that could be problematic. And often this will change the sensory experience of the person, because now that they have this relationship, the area that's being negatively affected by the limit being created by gripping or whatever it is can produce the force and the control it needs to control the joints and the stressors, the forces and energy inside the materials that are getting beat up because of when they do grip something, it limits that area's function. And so they start feeling better. To me, it's amazing to watch, really, right? Mm-hmm. Not only do their motor outputs start to go up, because I'll measure grip strength right to left and baselines and pre and post, and I'll start to see their force production go up, and then all of a sudden they can lift more weight with their shoulders, and with their arms, and it's wild to watch it. And then they start saying, hey, my hands used to really hurt, my elbows used to really hurt when I would do exercises with barbells and dumbbells. Hmm. And once I got their hands, and the rest of their system integrated, their hand strength went up, their extremity strength went up, and they didn't feel any problems in their elbows or shoulders anymore. So it's just like, what the heck? It's like, wow, okay. You just needed to learn how to coordinate those things. And that old injury and surgery and tendon transfers and whatever happened disrupted what? That internal spatio-temporal map, that hub link node network and all the streaming connectivity somehow got changed in a way that created a limit. And until that was addressed, the limit remained, and compensations ensued, and then those compensations put stressors on other parts of the system that were kind of tired of having to take those stressors, and those parts of the system started to say, what? Why do we have to do all this? Or we can't do this very good, because every time you're holding something in your hand, we don't get the information we need to control ourselves anymore very good. And we're taking all this force, and you keep pushing us to do more, and now we got material stress.
It seems like the compensation seems like because the body would have to compensate. Let's say you had a surgery on your hand, it has to compensate to be able to continue going about its day, because if it didn't, it would continue to use the hand in the same way and potentially cause more damage. So is the case that the body's great at compensating but not so great at returning back to normal, but back to, I suppose, homeostasis?
Well, it goes back to that example, right? Once it learns a new way, whether that's good or bad for it, in the long run, it just stays that way. It doesn't automatically reteach itself. Apparently, in many situations. Sometimes it might, but many situations, especially in the area of physical trauma, surgical interventions, material alterations, and disease. In my observation. So that's why that history is so important, coupled with the sensation. So that's why you always see me and hear me talking about the material control sensation paradigm, because the information is contained in, it's being presented to you that way. And so it's like, okay, because we can't see everything and measure and quantify everything that's happening at any one moment, it makes it really hard to figure out, okay, how do I solve this problem? What is the problem that I can observe?
Yeah.
And this takes some time, which is, my instructors and I and some of the specialists were talking about, what's happening in exercise now, and, the remote coaching like you do. And, they're talking about, okay, how do we go from where we are to remote coaching? And for, you as a remote coach, how do you go from remote coaching to where the muscle system specialist is trying to say, right? Can't do perturbations, can't do SARS, you can't do these screens, right? So the conclusion is, well, when you have to take tools out of your toolbox, you're limited now. You're just limited. You're not going to solve more complicated motor output problems remotely. You can't do it. It's not going to happen.
2 seconds. I'm just going to close the door.
Okay.
They're not my kids. I've got a shared garden.
I was just going to say, wow, okay, you got some chillins, huh? But yeah, but can you help somebody still? Yes, of course, you can still help somebody. Yeah. But to say, without doing these screens and assessments and this field work to really, find out if you can improve their situation, whether you know causation or not. And most of the time you probably won't know direct causation. Can you still help them figure out the relationships that create limits and potentials? Remotely, you can't do it. Yeah, it'd be tough.
Yeah, I think that there's some ways if you get inventive, but a lot of things that I've been doing is especially if it's a couple, or I'm coaching one of the couples, one of the partners, is getting them to film their partner doing a perturbation that I've sent a video to them. So if say I want to see if they've got some quality control issues just in the shoulder, in flexion, okay, get your partner to film and pushing down on the wrist and see left to right, see if you notice a difference. it's a long-winded way of doing it, but it's the only real way, I think. And just trying to be as imaginative as I can in explanations. But yeah, you are limited. I think there's when it gets to that point, it's like knowing your lane. You go, okay, well, I'm a strength and conditioning coach. I can't, to an extent, I can't really solve painful problems. If that happens, you need to go and find a physiotherapist or recommend someone.
Yeah, you got to find somebody to see if they can start, taking the samples and looking at you, up close, and so
that's got problems of its own. One of my clients, he's out in Australia, having some back problems that he's had for a long time. I knew him from the army, and what he didn't tell me, I was questioning him. Okay, like, what's happened? Have you ever had any head injuries? He's like, yeah, I was in a car crash once. I was like, okay, you might tell me a bit about that. He's like, yeah, I got a concussion. I'm like, okay, cool. Was it bad? And he's like, oh, it's pretty bad, playing it down as he would. As a male.
Yes, I was knocked on. My skull was crushed. I was in a coma for 2 weeks, but I'm okay now. Right?
Yeah. So, in hospital, unconscious. It was for 2 days. So I'm like, you say, yeah, that could have an effect. And I was like, okay, so what I want you to do is find a physiotherapist in your area that understands concussion and its impact on like the motor system. And he's like, I've looked and I've asked, I can't find anyone. He's immediate in his area. So that's there's problems with that as well.
Well, there's our opportunity, right? We have to, I guess, not to sound arrogant or narcissistic about it, but we need people around the world that have at least think in this lane, right? Not that the way we're talking about is the best or the only way, but it's a kind of a new way, and at least a creative way to access the motor system to see whether or not, motor outputs and the limits or potentials of them are related to whatever the other sensations that this person is experiencing that they don't like, are. Because until those get cleared up for him, if they're there, it's not going to get much better.
All I could do was explore some of his ranges of motions through, do some lunges, find, I drew on the kind of Gray Institute type stuff. Let's do some lunges. Let's try and fix the areas that we can, a week that I can observe from the other side of the world through video. And that seems to have helped so far. And now it's just a process of progressing conservatively his strength work, because for that individual, they're looking to go into a special forces setting. So it's okay, well, I can't treat you like a high performing athlete where I'm just going to throw stuff at you and make you overreach. I've got to do it quite conservatively, because we're dealing with a hidden problem here. We can't treat as such. So that's the only real way I found to do it in terms of remote coaching. And
you might be, again, you might be able to try have him like do a shoulder abduction reflection with some load on it with his eyes open, and then have him go through the motor screen, eyes closed, look left, look right, and see if he can detect, oh wait, my left shoulder, it doesn't feel as strong anymore when I'm eyes closed looking left, right? And you're like, okay, maybe you can try that. Have him turn his head, and use his shoulder. See if maybe he can detect for you, something in the process. So maybe you could try that.
Big thing. Look, obviously, the thing that we lose is the feedback and our physical interpretation of what's happening. Yeah,
there's something very that basic definition of stability through perturbation, right? It's just an important field tool, right, to assess motor competency.
But like you say, it's just limiting. You have to just do what you can at that point, and then go, look, be honest, and this is where we are. I can't do any more from here.
Yep. Battle wound in the middle of battle. You get a battle wound. What do you do? Here's stitch it up, put a patch on it. Here's some morphine. Hang in there, baby.
In a helicopter, and I'll see you later. I'll carry on fighting.
Hang And, so, okay, it's, you do the best you can. Right. And
So in
again,
terms of this, like the cranial nerve column and stuff like that, interesting just to learn a bit more, and if you could recommend where I can learn a bit more about it. What led you on to that? Was it just, okay, you started looking at the neck and started looking at like motor systems and essentially where it led you down?
Yeah. So then, once I got on to the, wait a minute, this thing really is interconnected. And then you see all these weird relationships and you go, what else could be happening here? So how is the hub link node network kind of structured? So it's looking at straight neuroanatomy, right? And be like, how is the nervous system really structured? And I was looking at the cranial nerve column, and I think I was studying the hypothalamus first. And I was like, the hypothalamus is critical to this HPA axis thing, and it's editing, revising information, and not all the information being generated in the peripheral system, and anything below the cranial nerve column, the hypothalamus, not everything is getting up to the brain, because you have this little tiny area, a hub in the system saying, okay, we'll take the information in, but we're going to reduce a lot of this. We're not going to send everything through. And we might edit it a little bit too, and when we send it through. And I'm like, man, that's incredible. How does it choose what information to send through? And then so I started looking at that part of the brain, the spinal cord above the foraminal hole in the cranium, right? That's the mechanical or the anatomical demarcation, is all the motor neurons and in the ventral horn and sensory neurons in the dorsal horn that are part of the spinal cord, which is the part of the nervous system, that's outside of the cranium. Foramen magnum, I think they call that hole. But the spinal cord keeps going up into the lower part of the brainstem, the base of the brain, and that's where that cranial nerve column is. And so I was wondering, because I've always tried to figure out, how can I access more? How do I access more of the system's motor output? Eyes, auditory, tongue, right? So that got me into, well, where's the motor pools and the sensory pools for these structures, for these mechanical structures, and they're in the cranial nerve column. And again, given the hub link node network and proximity, and then the realization that there are motor units in the cranial nerve column that innervate peripheral skeletal muscle, your trapezius, right? Your scalenes, your SCM, right? Your suboccipital muscles, which are all part of the neck, and also have motor pools in the spinal cord below the cranial nerve column. And so now, why would that be? Because of what? What my eyes and my ears and my tongue and everything, what that's attached to what? My neck. It makes sense that there's a relationship there. That what my head's doing and what my eyes are doing and what my shoulders are doing and what my spine is doing, they need a direct connectivity so that they can coordinate their activities. And that made sense to me. That was my conclusion about that. And then once I realized, oh, wait a minute, the trapezius and the suboccipitals and the scalenes and these muscles have motor pools in the cranial nerve column that are right next to and very close, fractions of millimeters next to where the motor neurons that affect the eyes and innervate the tongue and the ears, right? They're all real close to each other in there. And the chances are they have what? Internuncial cell or interneuronal relationships. They can send information between each other. And then if there's a problem in that information change, it might show up in the neighborhood, right, somewhere. Just like what just happened. When we were talking, all of a sudden I hear this baby crying, and you have to leave, and you came back, and what'd you tell me?
My kids.
They're not your kids. You said what? You share a what?
Oh, yeah, share a communal garden.
You share a communal garden. So what's happening in the communal garden, because you share it, affects you.
Yeah.
Whether you like it or not sometimes, right?
more than
right? So sometimes it's nice to go out in the communal garden to see your neighbor and you say hello, right? And you get some strokes. And sometimes it's like, nope, it's too noisy. There's babies crying. I don't like the sharing, right? And so you get to what? Close the door. And so the nervous system is doing this all the time, opening doors and closing doors and changing relationships between connected areas. And sometimes it's beneficial to have the door closed. Sometimes it's not. Yeah, that's how I see it as a general system construct.
So in terms of, I suppose the question is our question to work out why it changes and closes door and things like that, or to work out the opposite of that. I don't know what that would be, how I'd structure that. Does that make sense?
Well, yeah. Whether or not the door should stay closed or not, right? Or we won't be able to change the door. Maybe there's a tumor in there, or there's some genetic problem, right? So there could be things we can't. Can we change the motor relationship to improve motor control output? Again, based on that concept of what we want the system to do as professionals, reconciled to what the subject wants their system to do, right? And then we think if there's errors in there, and then we think, can we clear up the errors in motor behavior? And sometimes we can. Sometimes you're not going to be able to. The door's staying shut because there's a tumor or they had a genetic anomaly. And that's just a motor behavior they're never going to achieve. But it's nice to know that, because now when I'm showing them exercises and putting stresses on them, I'm aware I've got to be a little bit more careful around here, because they're not going to be able to do something, and I found no way to improve it or change it or remove the limit. And that's okay. Now I know something. Yeah. But I'll always try initially to see if I can improve the motor output by the qualitative way we do that. And quantified, if you want to measure force and force per time and do count and measure things, it's great. But that's what I'm trying to do. And to see if there's sensational change. Sometimes it will, sometimes it won't. Maybe I can find a way around the door closed, right? Maybe the system, because of plasticity, we teach it how to do something new, and I can still get the motor behavior I want, but we had to create what? We had to drive plasticity. Come up with a new hub link node communication pathway. Okay. Now that could take a while, and the consumer doesn't always understand. This could take months of very repetitive process to get this thing to change.
Yeah.
Because we're fighting homeostasis. Body doesn't want to really change very much.
Yeah.
So yeah, that's where we're at.
That is where we're at. Yeah. A lot more reading to do.
Yeah, and I don't know. I'm surprised that there are other really people smarter than me. They're not thinking like this. I don't understand it.
This is again. I still keep coming back to the whole stretching thing, and I commented on a post yesterday, I think it was, about they were explaining about how if you've got Achilles pain, for instance, you can like test to lift the skin and then think about looking upstream, and you can smash and floss the calf. And ask the question, I was like, okay, well, what if there's no tendon pain? Wouldn't but there's a control problem. Wouldn't flossing and massage be a redundant process? You are just treating pain there, and there's no pain. And they came back with some answers that didn't really make any things clearer. So it's my thinking is why aren't people thinking like this in terms of like this whole interconnected system? Like as a sports therapist in the UK, like the eyes and the neck and things like that, they're not really spoken about. Is it because it's just too complex and they're going like, yeah, oh well, too complex for me?
I don't know. I don't know. It doesn't. I don't understand it.
Because the physiotherapists and sports therapists are the ones that are seen to that they should know about this stuff. Like,
you would think so. You would think, they're reading the books. They've seen the research. I'm not reading anything they're not reading.
Yeah.
So I don't know.
Not making the connection.
Yeah, or why? Yeah, why when you share the concept, they just are like, well, hold on a second. What are you talking about? What a bunch of silliness, right? Yeah. Again, it gets back to that material paradigm. Let's pull the skin. Let's floss the nerve. Let's floss the fascia, right? And it's really stuck, and that might help. It may be. All I would include with them is, why don't you check the pre and post motor quality to see if you change that at all.
And a lot of the time, like with the lacrosse ball, foam rolling and flossing stuff, it does change motor quality.
It certainly could. It has the potential
for a short period of time, but it doesn't last. That's where I got stuck with it. It's like it just wouldn't last. No matter how much I foam rolled my lat, my shoulder pain wouldn't disperse. It would disappear for a short while, and then my range of motion wouldn't increase. And I think I was fooled into thinking that I needed to increase my range of motion. Like I've always been relatively flexible, and I'm like, okay, I've got to get more mobile, more flexible. I kind of just ran into a roadblock every single time. I'm like, okay, well, I've been doing this for a long time now. Nothing's changing. I'm still in the same pain. For instance, when I came to see you, I had what I would perceive as a right side bent torso. And my right shoulder hung quite low. My right shoulder still hangs quite low. I'm still trying to figure that one out. But my torso is nowhere near as side bent. You could, like, if you looked at my chest, you could see the line. It was just a curve. It was like this, pretty much. And I'm very much straighter just by working on getting this side working more and firing better. I'm not for use the term firing. So I was fooled into thinking about firing patterns and things like that, trying to get certain things to switch on before other things. So that's what's confusing about the world out there. Is why, like you said, why are people thinking like this? Yeah.
I don't know. I just go back to that quote that I found that I put in the philosophy statement, which is, I guess, the book that I'm supposed to write.
Please do.
Let's see, where is that quote about exercise? It's about looking at the entire system, right? Somebody has to look. We get so bogged down in the reductionism, right? We have to look at the whole system. And I remember where I put that quote. Oh, here it is, by Dr. Loring Rowell. Where do you see the exercise science field, particularly your area of greatest interest, heading in the next 20 years? That was a question Dr. Rowell was asked. This field may play a more vital role in the biological sciences than we had once imagined. If the basic life scientists rush to apply their expertise to provide functional meaning to the genetic code as is expected, who will be left to teach basic human biology and physiology? Who will explore the functional consequences of aging, for example? Who will discover what controls breathing and the circulation during exercise? Who will do the systematic integrative science that reveals how whole organ systems and organisms actually work? These questions are not likely to be answered by reductionists like molecular biologists working upward from molecules to cells to systems. This is the wrong direction. I mean, I think that quote encapsulates what we're talking about. We're looking at what? Whole organism function, aggregate integrated motor competency.
It just makes sense to me to work from the system down. I do it because I potentially don't have the expertise to go the other way, but it just makes sense to me to go that way. I don't know. That's probably why I'm here talking to you today.
Probably, right? So probably just need to find more folks that like, and again, there's nothing wrong with being a molecular biologist and looking at, the mitochondria of a cell and figuring out what that's all about, and nothing wrong with that. It's great stuff. They incredibly brilliant things, and they find out amazingly good information from that can be useful. But can studying a mitochondria tell me why your shoulder doesn't work right? Nope.
Right. Definitely not.
Apparently not. So, all right, young man, well done.
Yep. Appreciate that.